Hello and welcome again to FlippedHarber for Algebra 2. In this video we're going to talk about section 1.6, Relations and Functions. Our objectives for this lesson are to identify the domain and range of relations and functions. And we also want to learn how to determine whether a relation is a function. Our topics, we're going to talk about what a relation is, what the domain and range for a relation are, and what's a function. How is it different than what a relation is? What we're going to do in this video is start by looking at what a relation is and what a function is. How are they different? What the domain and range are for relations and functions. We're going to talk about what a mapping diagram is. We're going to talk about the vertical line test, and then we'll get to some examples. Now, a relation, put very succinctly, is a pairing of input and output values. Now, that pairing can be expressed in a lot of different ways. We could use an equation, something like y equals 2x. That's a relation. If I plug in an x value, I get out a y value. We could use a graph, because we can read off points on that graph. Those points have an x value, an input value, and a y value, an output value. We could just give a table of values. We could use this idea called a mapping diagram, which we'll talk about, or you could even write out what the relation is. And that relation doesn't have to be like all mathy. We'll take a look at some of those. Now, one of the best ways to talk about a relation is in an ordered pair form, x comma y. Whenever you write it in ordered pair, it's always the input value first and then the output value. Our x first and then our y. Now let's talk about what the domain and what the range for a relation is. The domain is all the numbers that can go into a relation. What can we input into the equation? Where do we look first on a graph? The range is all the numbers that we get out of the relation. So here we have two ways to talk about the same relation. We have an equation, y equals x plus 5, and we have the graph for y equals x plus 5. This is a relation. The domain is all the numbers that I plug into the equation. If I plug 1 in for the number x, that's my input, and then I have a certain output for that, 6. On my graph, my domain is the x numbers that are covered up by the graph. So this graph starts all the way over at the left at -10, and it goes all the way over to the right, and it actually keeps on going over, even where I can't see it, even where the graph isn't visible on my screen. So the domain is the x values where the graph exists. The range, the output, are the numbers that I get out of the equation, or in the graph, my range is the y values for the graph. This graph starts way down at the bottom at about -5. It goes all the way up to 10, but it keeps on going up from there. It keeps on going down from -5. Just because it stops on my screen doesn't mean the relation stops. So my range in a graph are my y values where the graph exists. Domain is x, range is y. X, y. Domain, range. It's that simple. Now, a function. A function is a relation in which the first coordinate is never repeated. That means that there's no repeats in our domain. Now, something to remember is that every function is a relation, but not every relation is a function. So if we say something is a function, it is by default a relation. But if we say something is a relation, it has to meet this criteria before we can call it a function. Now, here's some mapping diagrams. Mapping diagrams are basically two boxes. One of those boxes is a list of all of our domain values. The other box is all of our range values. Now, the arrows always go from our domain box into the range. So even if the boxes aren't labeled, you can tell which one is the domain and which one's the range. The bottom example, because the arrows go from the top box down to the bottom box, I know that that top box is my domain values. Now, the first mapping diagram, the one in the upper left, is a function. The other two are not functions. Now, why are they not functions? Well, they're not functions because there are more than one arrow coming from a domain value. Whenever you see more than one arrow coming from a domain value, it is not a function. So the domain value 1 in the blue mapping diagram points to both the 5 and the 3. That's not a function. That means that there's a repeat in our domain. In the bottom example, the 3 has 2 arrows coming from it. That means it's not a function. There are 2 arrows pointing to the 9 in the bottom box. That's okay. That doesn't stop it from being a function. Now, great way to test and see if a graph relation is a function is the vertical line test. If they give you a graph and they ask, is it a function? Try to draw a vertical line that goes through the graph in more than one spot. If you can't do it, it's a function. If you can draw a vertical line that goes through the graph in more than one spot, it's not a function. So out of these 2 graphs here on the screen, the one on the left is a function. The one on the right is not a function. The one on the right is said to fail the vertical line test. Alright, let's get into our examples. In this one, we want to list the domain and the range for these 2 relations. We're not really worried whether these relations are functions or not. We just want to tell what the domain is and what the range is for each of these relations. Now, the domain and the range are going to look very different for these 2 graphs because the graphs look so different. The first graph, the one on the left, is what we refer to as a discrete graph. When you've just got points, that's a discrete graph. The one on the right, it's not a discrete graph. It's made up of a couple lines. So things are going to look a little bit different. For discrete graphs, for your domain and range, just list the x values and list the y values. We've got a point at 0, -2. So we list the 0 in our domain, we list the -2 in our range. We've got a point at 1, -1. So we list the 1 in our domain, the -1 in our range. We've also got a point at 1, 2. We don't need to list that 1 again in the domain, but we need to list the 2 in our range. Our last 2 points, we've got a point at 2, 0, so we list the 2 in our domain, we list the 0 in our range. But we've got another point at 2, 1. We don't need to list the 2 in the domain again, but we'll list that 1. So, right away, I see that there's only 3 numbers in our domain. There are 5 numbers in our range. This is not a function. Whenever you see more numbers in your range than in your domain, it's not a function. Let's look at the other one. Our domain is our x values. And because of the way the graph is made, every single x value is contributing to the graph. So our domain is said to be all real numbers. Our range, on the other hand, are y values. Only the y values -3 and 3 are used. So our range is a list of numbers, -3 and 3. Now, there's a lot more numbers in the domain than there is in the range, so this stands a pretty good chance of being a function. Is it a function? Yeah, we're going to see this graph again. Let's make a mapping diagram. We're going to make a mapping diagram for the relation listed here in ordered pairs. So the first number in each parentheses is a domain value. The second number is a range value. So we're just going to list our domain values, I put them in order, and we're going to list our range values, and again I put them in order, and we draw arrows. The -2, well, that makes the 5. The -3 also points to the 5. That's okay. The 4 points to the 4, excuse me, the -4 points to the 4, and then finally the -5 is pointing to both the 2 and the 3. As far as whether this is a function or not, that's a problem. So let's do an example where we decide, is a relation a function? And I've got here a couple written relations. From car models, so that's our domain, car models is our domain, to car colors. Is that a function? Well, no, it's not a function, because car models have more than one color. So if I went to a car dealership, I could see a Chevy Silverado that's red, I could see a Chevy Silverado that's blue, I could see a Chevy Silverado that's black. So I've got multiple colors coming from the same car model. Our other relation, from purchase price, that's our domain, to sales tax, that is a function, because for every purchase price there's only one possible sales tax, at least in the state. So if you go to a store and they say, okay, your bill is $200, they're not going to say your bill is $200 and you have to pay this or this in sales tax. There's only one number of sales tax that you have to pay. So that is a function. Let's run the vertical line test on a couple graphs. So is our first graph a function? We've seen it before. What do you think? What about our graph on the right? Is that going to pass the vertical line test? Well, the first one is a function. If you try to run a vertical line, it only goes through the graph in one point. Now, part of that is thanks to the open circle at the beginning of the top line. That's not actually part of the graph. It's just a label for where the end of the graph is by. So that is a function. Our graph on the right does not pass the vertical line test. We can draw a vertical line at 2 that goes through 2 points. Now yes, I could draw another vertical line at 4 and it would fail again, but it only has to fail once to fail the vertical line test. So the first one is a function, the second one is not. Alright, here's our homework again for this section. So that means we're all done with this lesson. Again, I hope you took good notes. I hope you wrote down all those examples, because those could show up on those notebook quizzes. So, we're all done. I'll see you in class and I'll see you on the videos.